Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 14 Sum. Okay, let's look at the question. Discuss the continuity of the function f where f is defined by. So here f of x is given. Okay, so for this given f of x, we are going to check the continuity, discuss the continuity. So we are going to check the continuity. So generally, along with the f of x, point will be given. At what point we are supposed to check the continuity. In case if the point is not given, then we have to check the throughout the real line. Okay, but here you can notice the domain. Okay, domain is from 0 to 10 only given. Okay, so if point is not given, basically what is the condition? Throughout the real line we have to check the continuity. So now using the if condition, so you can see some numericals here, 0, 1, 1, 3. So based on that, let's break the real line. So at 0, at 1, at 3, and then at 10. Okay, so now we have a first interval minus infinity to 0. Do we have a function for this particular interval? We don't have. That means it is not a domain at all. So these values we don't have in domain, so we no need to worry about the outcome. Okay, so we are not going to check the continuity for this. So for whatever they're asking, for that alone we are going to check the continuity. Okay, at x equal to 0, or do we need to check the continuity? If x equal to 0, generally to check the continuity, what are the things are required? F of 0 is required. Okay, then left hand limit and then right hand limit. And for the left hand limit, what is the meaning of the left hand limit of 0 here? That means less than 0. If x is less than 0, do we have a function? Obviously not. Okay, we have if x is exactly 0, if x is greater than 0, we have a function. Okay, but if x is less than 0, okay, we don't have a function. Okay, so at x equal to 0 also we no need to check the continuity. Okay, and here you can see one interval 0 to 1. Do we have a function which for the values which lies between 0 to 1, do we have a function? Yes, that means we have to check. So case 1 is we have to check the continuity for this particular interval if x is lies between 0 to 1. Okay, for this we have to check the continuity, and 0 to 1 we have infinite real values. Okay, so for the infinite real values, it's not possible to check one by one. Okay, so we can have a common name. Let's see be the any real value which lies between 0 to 1. Then to check the continuity, what are the things are required? F of c, left hand limit, right hand limit. All the three things we are going to find out. In case in left hand limit, right hand limit, if we are going to do the same f of x, then limits we can combine, and combinedly we can find out. Okay, so in the case 1, we are going to check the continuity for the 0 to 1. Okay, next in case 2, if x is exactly 1 at the breaking point 1, no, so at x equal to 1, whether function is continuous or not, we have to check. So do we have enough f of x here that we have to check? So if x is exactly 1, we have a function? Yes, so 3 we have. If x is less than 1, do we have a function? Yes. If x is greater than 1, do we have a function? Yes. So that means for the domain we have 1 as a in a domain. Okay, input value they have given here 1 1. So we have to check for the continuity if x is exactly 1. So this is going to be our case 2. Next we are going to check for this interval. Okay, if x lies between 1 to 3, do we have enough f of x, enough informations are there in the question? We have to check. Yes. Then case 3 we are going to check. Okay, next if x is exactly 3, for exactly 3, do we have a f of x and all? For f of 3, if x is takes the exactly 3, do we have a function? Yes. Last one we have 5. Then if x is less than 3, do we have a function? Yes. If x is greater than 3, do we have a function? Yes. So in case 4, we are going to check if x is exactly 3. Okay, whether function is continuous or not, we are going to check. Next, in this particular interval, okay, so if f of x lies between 3 to 10, okay, if f of x is lies between 3 to 10, do we have a function? Yes. If any value lies between 3 to 10, f of c, then left hand limit, right hand limit, all the things we have to find out. Why c means we have infinite values lies between 3 to 10, so we should have some common variable. Okay, now so this is going to be like a fifth case. So that means to solve this totally 5 cases. Okay, and one more breaking point is 10. No, so if x is exactly 10, we have a function. Less than 10, we have a function. If greater than 10, do we have a function? For the right hand limit, no. That means we no need to bother for, it's not in the domain. Okay, we no need to bother for whether at x equal to 10 function is continuous or not. So whatever points they are asking, whichever domain we have, for that alone we need to discuss the continuity. Okay, so that means totally we have 5 cases. Okay, so now case 1 is what? So in case 1, if x okay, x lies between 0 to 1, no, so 0 less than or equal to x less than or equal to 1. Okay, so infinite values lies between 0 to 1, so I'm going to have a common name. Let c be any real value, any real value. At the same time, c should be lies between 0 to 1. Okay, so here c means what are the already told, no, f of c, left hand limit, right hand limit, all the three things we have to find out, f of c. So any value lies between 0 to 1. What is a suitable function from the given first function? So whatever input, maybe always the result is 3. It's a constant function, no, so 3. Okay, now left hand limit and for right hand limit. Okay, now c lies between basically 0 to 1. The close values of the c for the left hand side as well as for the right hand side are both are lies between 0 to 1 only. Okay, so instead of finding left hand limit, right hand limit separately, we can combine and we can find out. Okay, so now limit x is approaching to c f of x. So suitable function is, that is constant 3. So whatever we substitute, no, always the result is going to be 3 only. Okay, for any input the result is 3 only here. Okay, now from this what we can conclude, f of c and limit x is approaching to c, f of x is same. So f of x is continuous if our x is lies between 0 to 1. Okay, next at case 2 we have to check if x is exactly 1. Okay, whether function is continuous or not, we are going to check. So in case 2, if x is exactly 1, if x is exactly 1, how to check the continuity? F of 1, left hand limit, right hand limit is required. Okay, so first f of 1, if x is exactly 1, so from the given what is the suitable function? First function, that is 3. Whatever input we give, always outcome is going to be 3. Okay, now for the left hand limit, right hand limit, no, see the left hand side close values are approximately 1 only, but those values are less than 1. If it is a less than 1, we have to use the first function. And for the right side close values are greater than 1. So if it is greater than 1, approximately 1, but it's a greater than 1, so we have to use the second function. So in place of left hand limit, in a left hand limit, there f of x we have to use the first function. For the right hand limit, in place of f of x we are going to use the second function. So since different function, we have to work out separately only. And like in case 1 we combinedly we found out, that way we can't we won't be able to do it. Okay, now left hand limit x is approaching to 1 from the left hand side, f of x. So what is the given f of x? That is 3. So just substitute it. Now whatever input we give, it's going to be 3 only. Now right hand side limit x is approaching to 1 from the right side, f of x. So right side close values of 1 are greater than 1. If it is greater than 1, we have to choose the next function, that is 4 we have to choose. So replacing f of x with the 4. So since it's a constant, whatever x is there, always it's going to be 4. Now you can see left hand limit, right hand limit are not equal. So what we can say from this? F of x discontinuous at x equal to 1. Okay, so case 2 done. Next case 3. What is the case 3? If any values lies between 1 to 3, no, whether it's a continuous or not, we are going to check. Okay, so case 3, if 1 less than x less than 3. Okay, so we have infinite real values in this particular interval, so we are going to have a common name. Let c be any real value. At the same time our c should be lies between the range. Okay, now to check the continuity, we need f of c, left hand limit, right hand limit. So f of c. So from the given, if any value lies between 1 to 3, what is the suitable function? That is 4. So f of x equal to 4. Then if x takes any value, it's going to be 4 only, since it's a constant function. Now left hand limit, right hand limit. Okay, now 1 and 3 we have here. We have taken like a c which lies between 1 to 3. Now close values of c for the left hand side as well as right hand side, those values also is going to be lies between 1 to 3 only. Okay, so instead of finding left hand limit, right hand limit separately, we can combine and we can find out together. So limit x is approaching to c f of x. So suitable f of x is 4. So replacing, now answer is going to be 4. Now from this we can conclude that f of c equal to limit x is approaching to c f of x. So here f of c and both are equal, no? So f of x is continuous in this particular interval. Continuous where 1 less than x less than 3. Okay, so for in this particular domain, function is continuous. Next we are going to check for at x equal to 3. That is going to be our case 4. So exact point. Okay, so if x is exactly 3, so exactly 3 means to check the continuity, f of 3 value, left hand limit, right hand limit, all the things are required. Okay, so first let's find out for the f of 3. If x is exactly 3, no, so what is a suitable function? You can notice here there is, here the bird eye like a only less than symbol, but here less than or equal to. So that means this is the suitable function. If x takes the exactly 3, if the input is 3, suitable function is 5. So f of x equal to 5. That is f of 3 also 5. Since it's a constant function, whatever input we give, it's going to be same only. So f of 3 also 5 only here. Now for the 3, left hand side closed values are less than 3. Right side closed values are greater than 3. So from the given, are the f of x are same or not, we are going to check. If it is different, separately only we have to find out. So if it is less than 3, so if it is less than 3, we have to use the second function. If it is greater than 3, so comparing x, so you can see it's a greater than 3, so we have to choose the third function. So 4 and 5, so which is not equal, so different functions, so we have to find out separately only. So left hand limit, uh, x is approaching to 3 from the left side f of x. So suitable function is 4. So let's replace f of x as a 4. Now whatever input, since it's a constant, so constant only going to be the result. Now right hand limit, x is approaching to 3 from the right side f of x. So suitable function is, right side closed values of 3 are greater than 3. So suitable function is 5. So now result is 5. So you can notice that limit, left hand limit and right hand limits are not same. So from this we can say that f of x is discontinuous at x equal to 3. Okay, next finally case 5. So this is the last case. So now in case 5, so where do we need to check? If x value lies between 3 to 10, so in this range, so 3 to 10 infinite real values we have. So case 5, so if x is lies between 3 to 10, okay, 3 to 10 equal to null, we already found. Okay, so 3 to 10. So now for this particular, in this particular range, now we have infinite real value. So let C be the any real value. Any real value. At the same time, C should lie in this range. So 3 less than, C less than 10. Okay. So to check the continuity, we must have three things. So f of C, left hand limit and right hand limit. Now f of C. Okay, so any value lies between 3 to 10, we have to choose the last function only, that is 5. So f of C is going to be 5. So now between 3 to 10 some value. So here we have taken the C. Okay, now close values of the c from the for the left hand side as well as from the right side, both are going to lie in the 3 to 10 only. Okay, so instead of finding left hand limit, right hand limit separately, we can find it all together. So limit x is approaching to c f of x, so suitable function is 5. So now applying the limit is going to be 5. So from this we can say f of c and limit x is approaching to c f of x both are same. So what we can conclude from this, f of x is continuous in this particular range. F of x is continuous. Continuous where if 3 less than x less than 10. So in this range also it is continuous. And we don't need to check for the 10 and all. Okay, for the right hand side, for to find while finding the right hand limit, we will not have a sufficient function here. So only for the given domain, we need to check the continuity, not for everything. Okay, it's not for throughout the real line. So here we can notice that the function discontinuous where discontinuous at x equal to 1 and discontinuous at x equal to 3. Okay, so from the given domain, the function discontinuous only at x equal to 3 and x equal to 1. So that alone we can write it. So from all the cases, f of x is discontinuous, discontinuous, discontinuous at x equal to 1 and x equal to 3 in given domain. Okay, so that's all the solution for this sum. So thank you for watching, and please do subscribe. Thank you.